Hello friends, today I am going to discuss linear regressions problem. So let's see, linear regressions just according to theory you can see the linear regressions like if you write dependent or independent variables. So if you write the y will equal to beta plus a plus beta x, and so y is dependent on the x. Similarly, if you write the x will equal to beta plus alpha plus beta y, so x is dependent on y. But I am using here the linear regressions like some Boston's housing price, and this is the machine learning project. So need to the improve your skill here. So let's see the import numpy as a np, import pandas as a pd, import matplot.pyplot as plt, and percentage matplotlib inline. So first look there, and this has been imported because I am using Google Colab. Yes, it takes the time because this is a big data. Look like this. It depends on the internet connectivity also. Another library, just sklearn datasets, imported, loaded a database because it is a inbuilt data has been given in with a sklearn. Okay, so I am going to the Boston, loaded the Bostons. Like this. So look, see here the data has been given, how to collect the data. So all details has been given. Now the look here the data. So I have collected the data from sklearn. So sklearn library contains the data, and now the keys, Boston.keys. The Boston.key means represent like a number of the keys contains in this data, targets, feature names, DESCR, file name, and data modules. But you need to understand what is this. So let's see, the all attributes have been given and each attribute has been described one by one. So you can easily understand if you read one by one. Now after that I am going to the features. So now the Boston's.feature underscore name, and you can see here CRIM, ZM, Indus, CHAS, NOx, RM, ACE, DIS, RAD, tax, PTRA. So this is the way we can see here the all features name, because look here the feature name has been given here. Similarly we can also write here the target, data, DSCR. So let's try one by one. So feature name, similarly I have written, so the feature name contains these value, and you can understand these value from here, attribute, right? So after that you can see here the target. So these are the numeric values, so I don't think so. Data, it contains the numbers, numeric value, and similarly print.Boston.target, it also contains the numbers, numeric value. And import a panda as a PD. Now frame data look like a data frame. This is the pandas library and data dot date. So let's see, look like this. So your structure, data structure look like this way. Like 0, 1, 2, 3 something look like this. But 0, 1, 2, 3, so first we need to the name, change these names. So if I want to write a 0, enhance of the 0, some specific name, so I can write here like a Boston dot data columns Boston dot features names. So you can write all these features names look like this. So features name has become. Now we can also describe all these columns to our features. So let's see, I am going to the price and Boston dot target. So the price has been added here. The new column has been created. Look there, new column has been created, and the Boston dot targets, I have created the new columns, and we need to the data informations. So data dot informations look like this. So now we can see all these informations. Similarly, data dot describe, I want to the describe, so the all numeric value has been described by your data. So look like this is a way you can data dot describe has been given here. Now data dot is null, so we want to see here, do you have any is null sets? So null sets means empty sets. So look here false, but I am not able to understand because I can see the top 5 and bottom 5, and there are the 506 rows and 14 columns. So this is the better way to understand data dot is null parenthesis dot sum, and I try to understand. So we can easily specify which column contains a null set and not null set. So let's see, don't have the any. So is null, have any null. Now we are going to the apply here the exploratory data analysis. So EDA this is called, and this is the most important because I am going to the apply here the some statistics like correlations. So I like to find here the exploratory data analysis. So we need to the get here correlation. So the data as a variable I have already taken, and so need to the correct here data dot CORR. This functions I am going to apply, and it will automatically correlate every one by one, like CRIM correlations with the 1. Look here, this is the perfect correlations. Here ZN and CRIM, this is the negative correlations, and same look here in this, and this is the positive correlations but not a good. Okay, so you can see that, but I am not able to complete I am not able to understand this numeric value. So we have to go here to plot this. So we are able to understand through a plot way because we are not able to read the AV. So we are going to the apply. I am going to the apply here import keyword as a SNS and SNS dot the pair plots. Pair plot always we compare like a between two. So let's see the SNS, and it has been created like this. So we can easily understand through this data like what type of the relationship between these two. It because I am using like 500 and approx 500 rows. So yes, it will take more time. So don't worry, wait and watch. I can see here. So Yes, it is taking a time, don't worry, because it is depend on the your capacity, like data and your laptop capacities, RAM, and each and every factors depends on this. So, but I think 1 minute 22 seconds, but I hope, because most of the time if you take a like a 1 lakh, 10 lakh, millions of rows and columns, yeah, absolutely it will take a time. But I can also use a reducer time whenever I use like a tensor flow, so it will take a less time. Yeah, it has been created, look here, so you can easily understand here. So where is the positive correlations, where is the, here is the negative correlations, here is also no correlations, here is also negative correlations. So we can easily visualize, yeah, here is a positive correlations. So after we visualize, we can easily understand. Now if you want to plot look like a x and y axis, like a x as a Rm and y as a price, you can also visualize like this. Yeah. This is a way you can also visualize any tool. So let's see my, and here you can see here that these NS, because C bond is here, and REG plot, and Rm X represent as a Rm. So look here, here is the positive correlations. So you can easily understand the correlations of the each and every one. Any two, one is the x-axis, another is the y-axis. So let's see this one by one. You can try and understand. So this is a way to understand correlations, and after that I will try to understand the next video, like dependent and independent variables, how it works. So thank you.